Okay, so we're going to continue with chapter P, section 2. We're going to start with negative exponents, and I didn't write it here, but it should also be dividing exponential expressions. All right, so we'll start with negative exponents. So the rule is that if you see a negative in your exponent, it's not considered simplified. And so in order to simplify it, all you have to do is move the base to either the denominator or the numerator if it's already in the denominator, and change the sign of your exponent. So change it to the denominator, it's going to become a positive, or change it to the numerator and it's going to become a positive. All right, so 1 over a to the n, or just a to the n. All right. Something very common that I see happen every single year, and it's a big mistake a lot of people make it, is that they see something like x to the negative 3, and maybe they remember to change the position of it. This is just it's not a fraction or anything. You would move it to the bottom, but then they make this negative. All right, just because you see a negative in the exponent does not make the expression negative. It just changes the position. If the base is negative, remember, we mentioned in the previous lesson, the base is this big number, or the big expression, the one that has the exponent, is your base. If the base is negative, that could change things. It could be negative, it could be positive, depending on what the exponent is and when you simplify it, right, and everything, right? But the negative in the exponent does not make the expression negative, right? So do not change the sign of the base just because you see a negative exponent. All right, so let me erase that. So again, something like x to the negative 3 would be 1 over x to the positive 3, right? Change the position. If you don't see a fraction, assume it's over 1. Oh, whoa, what did I do? Hold on. Assume it's over 1, and then you can change the position now, right? Now you see clearly that it's in the top, and you can move it to the bottom. If it's already written like this, then you would move it to the top, right, with the 1. And then if you're not comfortable with the 1 just disappearing, this is technically 1 times x to the 4th, but 1 times anything is itself, so you don't have to write that. All right, so if I see a 1 over x to the negative 4, change the position, it becomes a positive. All right, so let's try a couple examples. This first one, pretty simple. This is as basic as it gets. Y to the negative 4, right? The negative exponent is going to become a positive. You would change it, the position, right? So there's no fraction or anything. You can write the fraction. It would move to the bottom, right? So this becomes 1 over y to the positive 4. Just change the position, change the sign of the exponent. All right. This next one's a good one because remember what we talked about in the previous lesson. Parentheses will change the expression. Don't think that you're moving everything to the denominator or the numerator, right? It's just what has the negative exponent. In this case, it's only x that has the negative exponent. So you're just going to move the x to the bottom, right? And change the sign of the negative 4. So this is going to become 2 doesn't change because 2 doesn't have a negative exponent. X to the positive 4 on the bottom, all right? And then that's your final answer. It's fully simplified, all right? You know your answer is finished when there's all positive exponents, all right? And so similar story with this next one, right? X to the negative 5, you can change the position, move it to the top, and make it positive. And it's going to become a 3x to the positive 5. And that's all you have to do. All right. If it's a numeric expression, right, so something with a number, your base is a number, same exact thing, right? You can move it to the bottom and change the sign of the exponent. This is going to become 1 over 4 to the positive 2. You would just simplify it as needed. All right, so 4 to the power of 2, we should be able to do that, right? It's just 4 times 4, which is 16, so 1 over 16. All right, should be pretty simple. Same exact thing with number 5, right? Like I said in the previous lesson, right? Parentheses, the entire thing is being moved to the denominator. All right, so it's going to be, change it to the denominator, and change the sign of your exponent. Again, do not do anything with this negative. This negative in front, that's another mistake that I see, is that people see the base is negative, or there's a negative somewhere in front of your base, and you'll change the position. No, right? It's just a negative exponent that's going to change the position. All right, so it's going to be 1 over negative 4 to the positive 2. And again, negative 4 to the 2 to the positive 2 is just negative 4 times negative 4, which is positive 16. So we get 1 over 16. All right. And then this is different from an example like number 6, because here we don't have the parentheses. It is just the 4 that has your negative exponent. So you're just going to move the 4 to the bottom. All right. And then keep the negative on top. And the negative is just going to become a negative 1. So this is really going to become negative 1 times 4 to the negative 2. And then you can move this to the bottom. All right, and this is going to be negative 1 over 4 to the positive 2. And 4 to the positive 2 is 16. So it's just negative 1 over 16. Okay, so some more examples. Right, they increase in complexity, but still same exact idea. Right, so here, again, the only thing that's being raised to the negative exponent is this y. This x, again, if you don't see an exponent, assume it has a 1. Right, so we don't do anything to that. We don't do anything to this x. This is just going to be an x. And then this y, we're going to move to the bottom. Right, so it's going to be over y, and then we're going to change this to a positive 3. And then all positive exponents, so this is fully simplified. All right, so the next one, this time, everything, right, again, parentheses means everything is being raised to the negative 2. So I'm going to move this whole thing to the bottom and then make this positive. So it's going to become 1 over 12x to the second power. And then again, just like in the previous lesson, if I have multiple factors, I can distribute the exponent to each factor. All right, and this is going to become 1 over 12 squared times x squared, and then 12 squared, 12 times 12 is just 144. So I get 144x squared. All right. And then if you look at something like number 9, again, this 3, nothing special is happening with this 3. It has no exponent. But y to the negative 2 is going to move to the bottom. And then x to the negative 5 is going to move to the top. Right, so on top, we should still have that 3, but then that x to the negative 5 is going to go from the bottom to the top, and the exponent is going to be positive. And then y to the negative 2 is going to go from the top to the bottom. That exponent is going to be positive as well. All right, and then so this is our final answer. All right, and then something like number 10, right, I would go factor by factor, right? See what needs to move and see what's okay the way it is. It looks like 4. Nothing special is happening there, right? X to the negative 2 has a negative exponent, right? So I know I have to move x to the bottom. Y to the 6, positive exponent, nothing special is happening there, but z to the negative 7, that has a negative exponent, that has to move to the bottom as well. So what's on top is just 4 and y to the 6. What's on the bottom is x to the positive 2 and z to the positive 7. And then that's it for that one. We have all positive exponents. This is simplified. All right, so another case that you might see with negative exponents is maybe you see a fraction as the base. And the rule for that is if you have a fractional base with a negative exponent, just flip the top and the bottom and then just make it positive, right? We probably could have figured that out doing some more examples, but this is just a way to simplify it, right? So if I have something like 3 over x to the negative 3, right? To make this negative 3 a positive, you would flip these two. So it becomes x to the 3. I'm sorry, x over 3 to the power of 3. Sorry. And just like with factors, if I have things being divided, I can distribute this exponent to each thing that's being divided on the top and the bottom. All right, so it's going to become x to the power of 3, and 3 to the power of 3 and 3 to the power of 3 is 27. All right. And then we can go over dividing exponents with the same base. Now, the rule algebraically is if I have a to the power of m divided by a to the power of n, you're going to subtract those two exponents. So just like with multiplying, right? When we multiply, you add the exponents. When you divide, you subtract. All right. Another common thing that I see, especially with when I taught Algebra 1, is that they would cancel the bases. Honestly, I'm not quite sure how that works, right? Some people would see this and would just cancel these x's and say it's 7 over 3. It doesn't make sense to me, but to some people they might just see the same thing on the top and the bottom and they want to cancel it out. That's not what happens if you have these expressions with exponents and they have the same base. Keep the base, you just subtract the exponents. So x to the 7 divided by x to the third would be x to the 7 minus 3. And that would get you x to the fourth. All right, and same thing with numbers, right? Don't cancel the 5 and the 5. It would be 5 to the power of 5 divided by 5 to the power of 2. You subtract 5 minus 2. And you get 5 to the third. And then do some math. 5 times 5 times 5 is 125. All right, so let's combine everything that we've learned so far. Right, so if you have coefficients, right, again, just like in the previous lesson with factors, this 4 and this 16 are coefficients. You can simplify these, right? If you just saw 4 over 16 without all the variables, how would you simplify this? You would divide by a common factor. In this case, the common factor is 4. If you divide them both by 4, you're left with a 1 on top, and you're left with a 4 on the bottom, right? Divide them both by 4. Right, this becomes a 1, this becomes a 4. And then you can use your rule to divide x with x, right? So this is going to be x to the 6th divided by x to the 2nd. This is going to be x to the 6th minus 2. All right, again, you don't have to write this intermediate step, but if it helps, you can write it. And then you get something like this, 1x to the 4th over 4. If your coefficient is 1, you don't have to write it, right? So I can erase that. So just x to the 4th over 4 is fine. All right, and the next one looks pretty similar. Again, I would do coefficient with the coefficient, a with the a, and b with the b. All right, so if I'm doing coefficient with the coefficient, 5 and 30 share a factor of 5. I can divide them both by 5. On the top, I get a 1. On the bottom, I get a 6. All right, so I get a 1 over 6. And then with my a's, a to the 4th divided by a to the negative 2, I'm going to subtract the exponents. So I get a to the 4 minus negative 2, right? Minus a negative is going to get you a big plus, right? So 4 plus 2 is going to get you to the power of 6, but I'll write that in the final answer. And then b to the 5th divided by b to the 3rd, dividing with the same base, you would subtract, so 5 minus 3. And then in your final answer, it would be 1 a to the 6th, right? 4 plus 2, b to the 2nd, 5 minus 3, divided by 6. And then this would be your final answer. Again, if 1 is your leading coefficient, you don't have to write it. So your answer is fine just like that. All right. So let's do some more. Over here, I only have a coefficient of 3 on the top, so there's nothing more I have to do to that. X to the 6th divided by x to the 11th is going to get you x to the 6 minus 11. So it's always the top minus the bottom. And then this is going to end up with a negative exponent, right? 6 minus 11 is negative 5. Okay, but if you have a negative exponent, again, we know how to handle that now. We're just going to move this to the bottom. All right, just that, right? 3 is going to stay on top, so it's going to be 3 over x to the positive 5. All right. And then number 14, we have coefficients on the top and the bottom, so I would do 15 and 25. We can find a common factor there. It looks like they share a 5. So if you divide 15 by 5, you get 3. 25 by 5, we get 5. And 3 and 5 don't simplify further, so we can leave that alone. And then x to the negative 2 and x to the negative 5. You can choose to switch the positions and then subtract. That's up to you, right? So if you wanted to use the rule of negative exponents and move this x to the negative 5 on top, and there's x to the negative 2 on the bottom, and then divide, that's fine. But I'm just going to do all of it at once. I'm just going to, because I see the division, I'm just going to subtract the exponent. So it's going to be 3x to the negative 2 minus negative 5. Remember, minus and negative is plus. And then I have a 5 on the bottom. All right, so negative 2 plus 5 is going to get you 3, positive 3. Right? Can't forget your rules for adding, subtracting integers. And then you get this as your final answer, right? It's fully simplified because we have all positive exponents, and 3 and 5 don't simplify further, so you can leave this alone. All right, now here we have some pretty simple examples. So x to the 6 over x to the second. Pretty simple, 6 minus 2, right? If you're dividing with the same base, subtract the exponents, so this is going to get you x to the positive 4. Now the next one looks similar, but you're not going to get the same answer, right? And this time the 2 is on top, the 6 is on the bottom. So it's going to be x to the 2 minus 6, which is going to get you x to the negative 4. This negative 4 and negative exponents you move to the bottom. So it's going to be 1 over x to the positive 4. All right, so just little things that are going to make one problem different from another, right? And you should be able to handle all of it. All right, and if I had 3 to the 8th divided by 3 to the 4th, it's going to be 3 to the 8 minus 4, which is going to be 3 to the 4th. And then this is something that I should expect you to simplify. Right? 3 to the 4th is just 3 times 3 times 3 times 3. And then you can break it up, right? 3 times 3 is 9. Another 3 times 3 is 9. And then 9 times 9 is 81. So 81 would be your answer for this one. All right. And then something like 7 to the 8th divided by 7 to the negative 3. Again, it's going to be 7 to the 8 minus negative 3. So it's going to be 7 to the 8 plus 3, which is 7 to the 11. Something like this, I don't expect you to actually multiply 7 by itself 11 times. You're going to get a huge number. I'll tell you more in class of what I expect with the exponents. But generally, like above 4, you're good to just leave it alone, right? Unless it's like 2 to the 5th, right? 2 to the 5th is relatively small. But again, the specifics of that I'll talk to you guys about in class, right? But 7 to the 11th is fine. I don't expect you to actually work that out. All right. Some of the harder examples are going to be ones like these, where you have multiple things going on inside of your parentheses, and then you have that negative exponent as well. So this is what I like to do with these kinds of problems first. I like to do the negative exponent first, all right, because if I have a fraction, it's really easy to forget about the negative exponent until the very end. So again, if I have a fraction as the base of a negative exponent, I would flip it. So I'm going to do that very first thing. So I'm going to put everything that's on the bottom on top, and then everything that's on the top on the bottom, all to the second power. Now you have a choice here. You could distribute this 2 to every single thing that's on the inside, or you can simplify what's on the inside first, and then you can choose to distribute the 2. I personally like to simplify on the inside first and then distribute that 2, just because if you see too many variables or numbers to the power of 2, you might confuse yourself. So let's simplify the inside first, the inside. All right. If I look at my coefficient with the coefficient, all right, 4 and negative 3, they don't simplify, so I'm going to leave those alone. Now, if I do my a to the negative 3 and a to the power of 1, again, if you don't see an exponent, assume it's 1. Negative 3 minus 1 is going to get you a negative 4, so I'm going to have an a to the negative 4. All right? And then I have a b to the 4th over b. Again, a b is to the power of 1. And then 4 minus 1 is going to get you 3, so I get b to the 3rd. And again, this is all to the power of 2. And with that negative exponent, you can move that to the bottom. Again, we're still working on the inside. So this is going to get you 4 b to the 3rd. Those are the only things that are on top. This negative 3 is still on the bottom, and then my a to the fourth becomes positive. Again, this is all to the power of 2. And now I have less things in the base, so now it's a little bit easier to go ahead and distribute that 2 to every factor on the top and every factor on the bottom. All right, so this is going to be 4 to the second power, b to the third to the second power, negative 3 to the second power, and then a to the fourth to the second power. And then now you can just simplify this, and once you're done with this, then you get your final answer. 4 to the second power is 16. Power to a power, remember from the previous lesson, you multiply, so it's going to be b to the sixth. Negative 3 times negative 3 is going to get you a positive 9. And again, power to the power, you multiply, it's going to be a to the eighth. And then that's your final answer. All right, so these are some of the harder ones that you're going to have multiple steps in one problem, right? Take it slow and make sure that you're accounting for every single property of exponents that you could possibly account for. All right, this next one, the exact same thing. Again, I like to account for that negative exponent first, just so that I don't forget it later on. So I'm going to go ahead and flip everything and then make that exponent a positive. So I'm going to turn that negative 3 to a positive 3. And now everything that's on the bottom I can bring to the top. 9xz to the negative 1. And then everything that's on the top I can move to the bottom. So negative 3xy to the negative 2. And then now simplify everything on the inside here. I can do coefficient with the coefficient. 9 divided by negative 3 does get you a number. So I would replace that with a negative 3. Right, 9 divided by negative 3 is negative 3. And then it looks like my x's cancel out. Right, if I have an x to the first and an x to the first, or you guys could just recognize if I have the same exact factor on the top and the bottom, they cancel out. Right, cancel out a common factor. So there's no more x here. All right, and then z to the negative 1 doesn't combine with anything, but I can move that to the bottom. So it becomes z to the positive 1. And then y to the negative 2 that's on the bottom, I can move that to the top and make that a positive exponent. All right, and then again, all of this is to the power of 3. All right, I know I did a kind of a lot in that one single step, just applying the properties of exponents that we went over this lesson. And now it looks like there's nothing else on the inside of the parentheses that you can simplify, so I would distribute that 3 to every single factor on the top and on the bottom. So we get negative 3 to the third power, y to the second to the third power, and then z to the first to the third power. All right, and then negative 3 to the third power is just negative 3 times negative 3 times negative 3, which is going to get you a negative 27. Y to the second to the third is y to the 2 times 6 is going to get you y to the sixth. I'm sorry, y to the 2 to the third is going to get you y to the sixth. And then this power to a power, z to the 1 times 3 is going to get you z to the third. And then there's nothing more you can do to that. That's fully simplified. Again, a little bit more work than some of the other ones, but this is as hard as it gets for you guys. All right, so maybe on a test or a quiz, we're not going to overwhelm you guys with that, with those kinds of problems, but it's important that you know how to do them, right? Because later on, these things come up, right? That's why this is the prerequisite chapter, right? These things eventually show up in much harder concepts, right? So good that we're practicing it now. We're not done with this chapter. We have 2 more sections on exponents and radicals.